Okay, Mengquan, can you read our objectives for today?
Gladly. Lesson 13.3. Magnetic field pattern. Lesson objective. Think of magnetic field and magnetic field lines.
Okay, well done. So, today we are going to talk about the shape of magnetic fields. Now, the shape of a magnetic field has a lot to do with from the north to the south pole. Okay, now who can tell me where is the magnetic field the strongest?
The north and south. And
Okay, so the magnetic field is the strongest where at the poles. Okay, now tell me, the magnetic field, where does it start? Does it start at the North Pole or does it start at the South Pole?
North Pole.
north.
Well done, it
North Pole.
starts at the North Pole. Now, okay, this is picture A. Now, if we look at picture B, what can you tell me about these two magnets?
They are abstract and
Yeah, you can clearly see with the magnetic field lines that they are attracting each other. Okay. And what can you tell me about picture C? What can you see happening here? Nothing.
They repel. Link.
Okay, repel. Okay, can you see that these magnetic field lines do not interact with each other, they repel each other. Okay. So, yeah, we're going to look at the shape of the magnetic field, and then we're also going to focus on magnetic field lines.
Anh quay rồi.
Okay, so before we begin, not Ming. Can you read the first sentence to me? Can you figure it out?
Magnet can attract a piece of magnetic material without touching it.
Yeah, well done. Dewey Bell, can you read the next one?
it's because magnetic have a magnetic field that surrounds it.
Okay, this is because
Because
Magnets.
Magnets
okay,
have a
have
magnetic
a
field
magnetic field.
that surrounds it.
Any
okay,
Any
magnetic material,
the field
okay.
will
Viet An, you can continue.
any magnetic material placed in the field will be attracted by the magnet.
Okay, does this make sense?
Yeah.
Okay, so basically what this sentence says, like we have okay, magnets, and magnets can attract any piece of magnetic material. Now, what is magnetic material? Can you name a few examples?
iron,
Okay, iron. What else?
Awesome.
Can you remember what other things get attracted to magnets?
Steel.
Yeah, other magnets, but so we have iron,
Steel,
steel, okay,
aluminum,
Gold,
aluminum,
Copper. Copper.
aluminum is not attracted to magnets.
nickel.
Okay, nickel, okay. So magnets can attract a piece of magnetic material without touching it. This is because magnets, okay, this is the North Pole, this is the South Pole, they have magnetic field lines that start at the North Pole and they go into the South Pole. Okay, and anything that moves into this magnetic field would immediately be attracted to a magnet. Okay. Okay. Now, magnetic fields presented here in picture A, the magnets, would they attract or repel each other?
Attract.
They would attract each other.
Attract.
Attract.
Okay, why do you say so?
Unlike pole. Unlike pole.
Okay, and in picture B, would the magnets attract or repel each other?
Repel.
Repel.
Okay, why would they repel each other?
Like pole.
Okay, and in picture C?
Attract.
Attract.
Okay, and then the last picture, picture D?
Repel.
Repel.
Okay. So, if we look here, like here you can see the magnetic field lines. The north and the south poles would attract each other, okay? Here you can see the magnetic field lines pushing away from each other. This means that the magnets would repel each other. Okay. And here you can see the magnetic field lines pulling towards each other. So it will attract, and here you can see the magnetic field lines pushing away from each other. They do not interact. So we say it repels. Okay. Nat Ling. Nat Ling.
Hello?
I'm here.
Alu.
Okay, can you read the first sentence?
A magnet field is field.
Invisible.
Yeah, well done. Field is
Oh.
invisible. It's not something we can see. Now, here are two ways to see the shape of a what?
Magnetic field.
Okay. Next
Iron
sentence.
filing.
Nothing.
Iron filing.
Okay, can you read the full sentence?
You could use iron filing. This
Okay,
tiny
next
piece
one.
of iron. This tiny piece of iron filings align with the magnetic field.
Line with the magnetic field of a bar magnet. Okay. Ewan?
How do you make iron fillings like get some iron and just scrap it fill it into small particles?
Okay. Ewan? Not here. Tui?
Wait,
We
wait.
Tui?
Teacher, I think
Yeah. Yes. Speak today. Okay, I'm not gonna wait forever for someone to reply. Nok Lin,
Yes.
can you read the next sentence to me, please?
Okay. You could also use small compasses that are called the bar magnet compasses.
Almost.
Line up plotting.
Right.
Okay.
Plotting.
So you use small compasses that are called plotting compasses. Okay. Now, a plotting compass is it's a small compass. Now, if this is the North Pole and this is the South Pole, to which pole would the compass point?
North.
Yeah. Do you see this? Do you see how the iron filings line up with the magnetic field? So the compass would also line up with the magnetic field. If I put it over here, it's going to point towards the north. If I put it over here, okay. Do you understand?
Yes.
Okay. Compass would what?
Line up.
The compass
Mhm.
would line up with the pattern of the bar magnet.
Yeah, well done.
Oh.
Oh.
Okay. I can see how that's two is different, but it's okay. Okay, you're able to hear this.
No.
I cannot hear.
All right, Dalen. Well, last year you probably remember talking about
Hey, oh, you heard this?
Yes, we can. It's just
Yeah.
something.
Yeah.
magnets in science class, right? And we looked at some different properties of magnets, and one of those properties was that all magnets create a magnetic field. That's those invisible lines of force around the magnet. We can't see it, but that's what lets it attract things or repel other magnets and things like that. It's because of that magnetic energy surrounding it. Now, I've got a magnet on the other side of the paper here, and you can see our magnet has a north pole and a south pole. This is just a regular bar magnet. And the magnetic field around that magnet allows it, you can see a little bit of iron powder that's actually stuck on there from earlier, but that magnetic field we don't really see yet, right? And we talked about energy being something that we can't see, but we can see its effect on other objects and other materials. So what we're going to do, we're going to use some iron filings here to see if we can observe the magnetic field. And I'm just going to let you just get you a little scoop there. And I just want you to just very, very lightly sprinkle it over our paper here. And let's see if we can see a magnetic field from that magnet.
Okay, so tell me, what is he pouring over the paper?
Iron fillings.
Iron filings. Okay.
Filing.
Just sprinkle a little bit of just a fine coating on there. There you go, a little bit finer than that. Okay. All right, so you can kind of see that iron.
Okay, so tell me, where can you see, where is the magnetic field the strongest?
Two poles.
The
Two poles.
pole. Two
At the
poles.
two
Areas.
poles, okay. And can you see the magnetic field lines that are forming?
Yes.
Yes.
Can we see that with our naked eye?
No.
Yes.
No.
No, it's invisible to our eyes, but as soon as you use something that is a magnetic material, it would align with the magnetic field of the magnet.
Powders, it's starting to do something, right? Starting to kind of line up along those lines of force. And we're just I'll let you just put that back in the container there. Let's shake it out a little bit. Let's just see if we can line that up a little bit more. But you can actually see those lines of force there between the magnet's two poles.
Okay, so you could use what?
Iron filings.
Okay,
Tiny
and
piece.
these?
Tiny pieces of iron
Fine.
line up with the magnetic field of the bar magnet.
Why check it
Well
out?
done. Yeah. Well done.
And you can see a lot of it's kind of attracted onto the magnet there, sticking to it. So what I want to look at next, we talked about magnets when we put them together. If you take the north and north pole of two magnets and put them together, what do those two magnets want to do to each other? They repel. They want to push away, right? So let's just look at how that affects magnetic fields. I'm going to set that back to the side. And right here, I have two magnets that are north to north, repelling each other. Let's turn this over. I'm going to borrow this for a minute, and we're just going to sprinkle a little bit on.
Okay. So magnets can either attract or repel each other. Now, in these rules, what does it mean?
Like
poles, unlike poles,
Unlike poles.
unlike Paul.
Unlike.
Unlike.
Opposite attract.
Different.
Different.
Repel.
Repel.
Wait. One would be north. One would be north.
North, not repel.
North. Attract.
Okay, how can you remember? Like, we can remember what? Opposites?
Opposite attract.
Okay, so remember in chemistry and in science and in physics in general, opposites attract each other, like a negative and a positive charge would attract each other. Just like the north and the south pole of a magnet would attract each other. Now, poles that are like would
Repel.
repel,
or
similar.
similar poles repel.
And as we sprinkle it, you'll see starting to line up to the magnetic field. And you can see right here are the poles of the magnets. Okay? But we've got that gap, that empty space in here.
Okay, so tell me, why do we have this empty space right here?
Because the two poles are repelling each other.
Yeah, so this is north and north. These two poles are repelling each other. They're pushing away from each other. And as you can see that the magnetic field patterns, like they will push away. Okay.
Here, because what's happening to those north and north poles? They're repelling. It's wanting to push away there. So that force, that magnetic field's wanting to push away rather than pull these together. You can see around here it's kind of pulling around towards the opposite poles at the back. All right? And the next one I want to look at, we're going to take two magnets with opposite poles. And we said like poles repel, what do opposite poles do? Attract. They attract, and that means they want to pull together. It's like when you take two magnets and stick them to each other, right? They're attracted to each other, and that's that connecting, pulling force. So right here, we have a south pole and a north pole lined up, and that's going to give that attracting, pulling force between the two magnets. So when we sprinkle our iron filings on here, let's sprinkle it real lightly so we can see it good. And you can see it looks quite a bit different. We'll put them side by side and compare them here at the end. Tap it a little bit, it'll make us see them better. But see right here, remember before it was pushing everything away out of the middle? See our first one there, everything's being pushed away, but here it's being pulled together as the two magnets attract each other. So that's a good representation. Using iron filings, we can actually see the shape, we can see the direction, and we can see the interaction between the two magnets with their magnetic fields.
Okay, so we can also use a small what?
Compasses.
Compass.
Okay, and what are they're called plotting compasses. Now these
Compasses.
this would align
The magnetic field of the bar magnet.
Bar magnet.
Okay.
You need to practice your English, William.
Compasses, compass, bar magnet. Well done. Okay, now let's look at this. So here we have the North Pole and we have the South Pole. And we know that the magnetic field moves from the North Pole to the
South Pole.
South Pole. Okay, here it moves from the North Pole to the South Pole. Now, if we place a small compass next to a magnet, the compass would align with the magnetic field. Now, it will always point in the direction we'll point in the direction of the magnetic field, but I will point towards the north end of the compass. So here's a compass, and then you have one that indicates north and one that indicates where south. Now, the north one, it is attracted to which side of the magnet?
The north? The south?
Let me draw it bigger. So here we have a compass. That is the north part of the compass. So remember, a compass is also, this piece of metal is also magnetized. Okay? And what do we know? Like, this is the north part of the compass, and this is the south part of the compass. So the north part of the compass, where would it point to? Would it point to the South Pole or the North Pole?
North.
The north pole of the compass. Would it point to the South Pole or the North Pole?
North.
Okay, so what did we just learn? We learned that magnetics, so here I have a magnet. So tell me, which side is the North Pole? The top or the bottom part?
The top.
Top.
Okay. So this is where I don't want you guys to get confused. So imagine a compass is a bar magnet. Okay. Now tell me, where is the north point attracted to? Is it attracted to north or to the South Pole?
South.
Good.
South.
So this would be the South Pole and this would be the
North.
North Pole.
North.
Okay. Look at this. Here goes the magnetic field. The magnetic field is going to go all the way around, but it's going to align. It's going to look at the South Pole. Okay. Or maybe it will become clearer in the next slide. Okay. Good. Ming Quan, can you read the first sentence, me, please?
Okay. We can represent the magnetic field of a magnet by drawing magnetic field lines. These are imaginary.
Imaginary.
Okay. Now, Lin, can you read the next one for me, please?
Magnetic field lines start from a North Pole and end up at the South Pole.
Okay. Zui.
Yes, see.
Vi Bảo.
Yes, teacher.
Okay, can you read the next one? They show.
They show two things about the magnetic field.
Okay. Đăng Tài.
Yes.
Can you read the next sentence?
The arrows shows the direction of the magnetic field. Where the lines are closer together, the magnetic field is stronger.
Okay, well done. Okay, so if we look at this picture on the side, where the magnetic field lines come together, this is where the magnetic field is the strongest. Okay. Good. So if I show you this picture, how, and I put these tiny compasses on, like remember, these compasses work the same as a bar magnet, okay? So this would be the north pole and this would be the south pole. Why is the north pointing in this direction? Why is it pointing in this direction? Because it aligns with what? It aligns with the magnetic
Field.
lines, okay? And this magnetic field line is on its way to the
South.
South.
pole. And we know that north is attracted to
South.
south, okay? And the south pole is attracted to the
North.
north, okay?
And the line
So,
is so
if we look at this one, can someone draw in how that compass would look like?
Wait, what? I have a different kind of compass.
Where would the arrow of the compass point to?
The north.
Okay, I can see someone starting to draw in. Well done. Okay, and this one, how would the compass look like if you place it there? Okay, and how would this one look like?
I have a compass.
Okay, close. But this one would, this one would align with the magnetic field. Now, if this is a bar magnet, remember, this is going to be north and this is going to be south. And it wants to point away from the north. It shows you the direction of the magnetic
Field.
Okay, do you understand?
Yes.
Yes.
And what will happen if I put a bar magnet right here? Where is it going to point to?
Outside.
Can someone draw that in? Okay, so here you can see the magnetic field line going, so it's going to point in the same direction. Okay. It's going to point in the same direction. And if I put a magnet over here, if I put a compass over here, it's going to point in the same direction as the magnetic field. And remember, when we have a compass, the arrow always points to
The north.
North.
Okay. Why does it point to north? Because it's attracted to which pole?
South.
It's attracted to the south pole. Okay.
My ears.
In the not-too-distant future, scientists may be able to simply scan a star for Earth-like planets and find the signature of life there.
We can look right at the light from a little planet around its distant star, and that opens up a whole range of possibilities for us to not just detect the planet, but to study the planet.
I mean, this all sounds like science fiction, but there is a reality to this. We have a scientific method to actually determine whether there is life on another planet.
Life is one thing, intelligent life another altogether. That requires billions of years and a powerful force field like the one we owe our lives to every day.
Okay, so the magnetic Earth. People use a what to help them find their way around?
Compass.
Compass.
Okay.
Compass.
compass has a what?
Have a needle.
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 Can you
Magnetize.
read the sentence at the same time?
Magnetize.
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 Turn
Can
around.
turn around.
Around.
Turn around.
North
North to
North
south.
to south.
to south.
Okay.
If an alien astronomer were to file a report on our home solar system, they might make a surprising observation. Because of all the 8 planets that orbit the sun, they could easily conclude that 2, not 1, were suitable for life. It's an easy mistake to make, because the sun has 2 planets within its Goldilocks zone, the Earth and Mars. Both planets have surfaces warm enough for liquid water to pool on. But while the Earth is blessed with warm, liquid oceans, Mars is dry and dead. The one crucial difference between these 2 planets could be the key to finding truly habitable exoplanets: a magnetic shield.
Okay, so the main difference between Earth and Mars is that Earth has a
True.
magnetic field.
True.
Okay.
Our sun is constantly hurling deadly radiation out towards us. Only our magnetic shield, the magnetosphere, saves us. Without it, the solar wind would blow our atmosphere away, and without an atmosphere, liquid water could not exist on the surface.
In order to have liquid water, not only do you need the right temperature, but you need the right pressure. You know, if there were no atmosphere here right now, even at the same temperature we are today, all of the water would boil off into vapor immediately.
So where does the Earth's magnetosphere come from? And why doesn't Mars have one? Actually, in the past, both Earth and Mars had magnetospheres, but Mars lost its around 4 billion years ago, and with it, the potential for life. Both the Earth and Mars were born into a realm of violence. Asteroids smashed into their surfaces, turning rock and metal into a molten mass. As they started to cool, a solid crust formed on the surface. But the molten metal below churned as the planets turned, inducing a magnetic field which rose high up above the surface of both planets. At the same time, active volcanoes pumped gas into the space around each planet. Protected by the newly formed magnetic field, these gases built up into thick atmospheres, creating the air pressure for liquid water to run on the surface. For over 100 million years, both Mars and Earth were warm, wet paradises, primed for life to take off. Then, quite suddenly, Mars's magnetic protection disappeared. The solar wind.
Okay, so as soon as Mars's magnetic field disappeared, what happened?
Water
It
started
lost its water.
boil
Okay, why did the water boil?
because it was right close
loss
to the
of
sun and the
magnetic field?
magnetic. There's nothing to protect it.
And radiation.
Okay, but what do we know about air pressure? Does Mars have the same air pressure as Earth?
No.
No. Why does Mars not have that air pressure?
No.
What do we have that Mars doesn't have?
Magnetic field.
A magnetic field. Okay. If there's no magnetic field, there's nothing to keep in the air pressure. And if there's no air pressure, water would just start boiling and escape into space.
Blew its atmosphere into space, and its oceans boiled away, leaving the dry, sterile red rock we see today.
Oh, that's dramatic.
So, A compass needle points north-south because okay, everyone can read this at the same time.
The compass needle points north-south because the Earth
has magnetic field.
magnetic field. It is as if there was a magnet
Inside
of
of the Earth.
A compass
Along.
the compass
Along.
points
Along.
along the
Along
lines of the
magnetic field.
Magnetic
Earth's
field.
magnetic field.
Okay, very smart, guys. Yeah. Okay, do you recognize this magnet in the picture? Or this compass in the picture? Okay, so let's see. So here's now for a class discussion. Now, why does the North Pole of a magnet, or the North Pole of a compass rather, point towards the geographic North Pole of the planets? Let me just, that needs to be a compass. Okay, why does it point towards, if I have a compass here, why does it point towards the geographic North Pole of the planet? Anyone? This is a class discussion. Anyone can tell me what do they, or should I call you out one for one? Nguyen, what do you think?
More land at the north.
Okay, so if I have a compass here, it's also going to point to the North Pole of the planet. Okay. If I have a compass over here, it's going to point to the geographic North Pole of the planet. Why is that? Ming Kwang, what do you think?
Well, because the Earth has its own magnetic field. Wait. But however, the magnetic field is like the reverse of a magnet. So the south of the magnet would attract to the North Pole, while the north of the magnet would attract to the South Pole of Earth, because the Earth's magnetic field is actually reverse of the magnet we know in use.
Well done. Okay, that is a very good explanation. So we know that the geographic South Pole of the planet, okay, is the North Magnetic Pole. You understand that? Hello? Can I get a yes?
Yes.
So out of the north, what do we know? Magnetic field lines start where?
From the north to the south.
From the north, and it goes to the
south.
South. It starts from the north and it goes to the
south.
It starts from the north and it goes to the south. It starts from the north and it goes to the
south.
Okay. Now, why do our compass needles point towards the geographic North Pole? Why? Fong? Fong?
Because North Pole attracted to the South Pole.
Okay, but this is the geographic North Pole and this is the geographic South Pole. But if I put a compass over here, which way is it going to point?
South.
North Pole.
The North Pole of the what? The planet or the magnet?
The planet.
Okay, so why would it point towards the geographic North Pole? Why?
No.
The compass is attracted to the South Geographic South Pole of the planet.
No.
There's a south here.
What you just said, like if it's attracted to the geographic, it is not this is the geographic South Pole of the planet. This is the geographic North Pole of the planet. But this is the magnetic South Pole of the planet, and this is the magnetic North Pole of the planet. Okay. So if I put a compass over here, where is it going to point? Is it going to point to the South Pole, or is it going to point to the North Pole?
The North.
Why is it going to
North
point?
Pole.
Well, why?
North Pole.
It's magnetic north. Magnetic south.
Not the magnetic North.
It's the magnetic south.
Yes. Okay, so this is the geographic North Pole, which is our magnetic South Pole. So a compass would always point from north to south. Okay. Do you understand?
Yes.
Do you understand why? Remember when you look at a compass, okay? When you look at a compass, that needle is magnetized. So it's almost like it's its own little magnet, okay? And we know that the North Pole would point towards the geographic the geographic North Pole, because it points to the South Pole of the
magnet.
Okay, so you all remember that the geographic North Pole of the planet is not the North magnetic pole of the planet. Yes?
Yes.
Okay. Now that's very important. And that is our lesson for today.
Okay.
Okay. Do you have any questions?
Start.
Okay.
So, are we all here? We are all ready. Good.
Natural disaster again.
Natural disaster again.
Yeah, we're doing our review of natural disasters, and we've also got a little project that I'm going to introduce for you. So we're going to do some different ideas for you. And then we'll be moving on to our next topic in next lesson. Because we have quite a few lessons and not too many topics, I'm going to try and stretch out our units and stretch out our lessons to include all the information and all the difficult concepts that we can. So natural disasters, I'm going to give our little review, but we're going to turn it into a little review quiz for you. So what we are going to do, firstly, we're going to roll our virtual dice that we can get onto our screen. And then we're going to, this dice roll from 1 to 6 is going to represent a different category. So if number 1 on the dice, it's key vocabulary from the unit. Number 2 is use of English. Number 3, volcanoes. Number 4, tornadoes. Number 5, droughts. And number 6, earthquakes. We're going to do 5 questions first, and I want you to write down the answer to each of the questions on a piece of paper, if you have some paper next to you or your notebooks. So get some paper or your notebooks to write down the answers to 5 questions, and then I'll reveal the answer to those 5 questions. And we'll see how many points we have. And we'll do up to 15 questions. So, are we ready? Everyone ready? Good. Okay, so let's roll our dice to begin. 6. First question is on earthquakes. Some of these questions might be a bit challenging, so we'll see who can get the answer. Don't worry if you don't get the answer. So, first question is earthquakes. Here it is. Can you name the plates that move that cause an earthquake to happen? So write it down. I'll repeat the question. Can you name the plates that move on the earth to cause an earthquake to happen? So I'll give you a bit of time to write down your answer. Good, so you should have written down. Don't worry if you don't know it, as it's quite a difficult one. So yeah, write down your answer, and then we'll go through. Question number 2 is going to be based on the dice. We'll go through 5 answers once we complete 5 questions, okay? So, next question is on 3, volcanoes. This question. Can you give me, so write it down, don't need to say it. Can you give me the word for what a very big volcano is? The word for a very big volcano.
Super volcano?
Yep. So write down your answer. Next question. Question number 3. 5, which are droughts. Your question is on droughts. Could you give me a short definition? So write down your answer. You don't need to speak it yet, but give me a short definition in 1 sentence of what a drought is. What is a drought? In a short sentence, and write it down. Okay, so I'll give you a bit more time to write down your answer. So you should write a sentence. And then, if we are all ready, question number 4, we'll roll our dice. 6, earthquakes again. What natural event from the ocean do earthquakes cause?
Tsunamis.
Okay, yeah, so write it down. Good, yeah. Is a tsunami is the answer. You can write that down. So tsunami. Good, I think we know that one. So that was question number 4. Question number 5. Our topic, tornadoes. Your question is, what type of rain is caused by a tornado?
Hurricane?
So what type of rain that falls from the sky is caused by a tornado? So you don't need to don't say the answer yet, just write it down because I want to say the answers all together. So just write it down. What type of rain that falls from the sky is associated, connected with a tornado? Okay, so those were our 5 questions. Let's see what answers you gave, and I can write down our answers. So for question number 1, was question number 1, what are the plates that are moved when there is an earthquake? The answer was tectonic plates. Tectonic plates move, causing an earthquake. Number 2, the question was, what was the very large volcano? And some of you said it, it was a supervolcano.
Me, I said it, okay?
Good if you got that. Number 3, give a definition of a drought. So we'll give a short definition. You should have written something like a long period of time without any rain. And you can also say causing a shortage or causing not much water, causing a shortage of water. Put there. So if you put something similar, that's also okay. You can get a point for that. Number 4 was also to do with where is question number 4? So question number 4 was what type of rain is caused from a tornado, and we will say the type of rain that was caused was hail.
Fish.
Rain that falls down from the sky during a tornado would have been hail. Good. So let's do another 4 to 5 questions, and then you can also write down your answers. Did anyone get 4 points out of 4?
Me.
Good. Well done. Anyone get 3 points out of 4?
Really?
Good. So well done if you've got some of those answers. Let's do another 4 to 5 questions, up to 10 questions, and see how many points we can get. So, next one now. Go to our virtual dice once more. Question number 5. Key vocabulary. Can you tell me what is the word for the land directly underneath an earthquake? So the land directly underneath an earthquake, the main part.
Tectonic plates.
So not tectonic plates. Okay, we'll go through each answer then. So let's give your answers. The land directly underneath the main part of an earthquake. Anyone else have any guesses? Begins with E. Any guesses? It is called the epicenter. Quite a difficult one, that one. The center or underneath an earthquake is called the epicenter of the earthquake. A difficult one. Let's do 10 questions. We'll do up to 10 questions. Question number 6. Use of English. Now, for number 2, I would like you to write me, if you can, or tell me, a sentence using the present perfect active. A present perfect active sentence. So if you need to, you can look through your books or look at your course book to remind you. And I'll give you a bit of time. and we'll see if anyone has a perfect active sentence. Do you tell me? Does anyone have any ideas? Anyone have any guesses for present perfect active?
The work has been completed by him.
The walk has been completed by him. You could say that's more present perfect passive, as the walk has been completed. So that would be a present passive sentence, but good effort, very close. I'll give you an example. So we can say they've been killed in the disaster. So you would have to say your subject, they've been killed. This would be the main part. I've been, then past participle, and it's part of your sentence. So present perfect active is they've been, or I've been, or she's been killed, or they've lost. The present perfect active. Another example would be they've lost. So straight away you could say a past participle. They've lost the game. You could say they've lost the game, you could say, for present perfect active. So those are some examples there. Let's move on to question number 7. So take a read through present perfect, active and passive if you're not sure of it. It's found in your books during this unit. And so let's do question number 7. Next dice roll. And number 2, we are on use of English again. I would like you to give me an example of a modal sentence, including a modal verb expressing possibility.
Bây giờ 10 giờ 10.
Modal verb. So what is a modal verb that could express possibility? This is a modal verb where you could say can or can't. Any sentence that you can say can or can't. So you can write down a sentence, or can anyone give me a sentence with can? He can, she can, you can. So any sentence using can. Could anyone give me one? An example? Any ideas? I'll give you one example. So you could say, these are the games you can play. Because it's expressing possibility. You can play them. This is possibility. Modal verb. So modal verbs to do with can, could, can't, things like that we did in one of our lessons. So again, if you're not sure, you can review yourself. You can take a look at your modal verbs. We'll do 3 more questions. Number 8. Done now, use of English. Let's use a different one. We can do 4. Tornadoes. Next question to do with tornadoes. What is the name of the area in the USA which has the most tornadoes? So what is the name of the area?
Tornado Alley.
Yeah,
Tornado Alley.
Good, well done. You remember that? Tornado Alley. And it has different states in the USA that has the most tornadoes. Good, well remembered there. Tornado Alley has the most tornadoes in the USA. Question number 9. You can see that number 5, droughts. Going back to droughts. Now, let's make it a little bit tricky then. What is the word? What is the word used for when you artificially water your crops or your land? It doesn't fall from the sky. It doesn't happen naturally. This word is when you artificially water your crops or land. You can take this water from a river, or you can take it from a lake and you artificially water your crops or land. This word begins with I. Any guesses there? Beginning with I. I'll give you the next letter. It's ir. Two R's.
Irritants.
Almost. Irrigation.
Irrigation.
Good. So when you artificially water your crops or land, it's irrigation. You take the water from a lake or a river and you water your land because you don't have any water because of the drought. So irrigation there. Good. And final question, let's do our last question here, is going to be on three volcanoes. See if we can make it. Where in the world are 3/4 of the world's volcanoes found?
Pacific Rim.
It's not quite the Pacific Rim, but that's a good guess. There are a lot of volcanoes there.
Firing.
You're on the right track with Pacific.
Firing.
Say again?
The Pacific firing.
Pacific. So I can tell you, I'll give you a clue. I'll give you 3 options, okay? So option number 1 is Antarctic. 2 is Africa. Option number 3 is underwater. So where do we think?
Underwater.
Underwater, correct. 3/4 of the world's active volcanoes, or 3/4 of the world's volcanoes are found underwater. So well done if you've got underwater there. So let's move on. We'll move on from our quiz. Any questions about the quiz or any questions so far about?
Somehow.
Okay. Well done if you got some. Well done if you got some of those answers. Let's move on to our quiz.
We'll have to be busy a bit. My grandma told me that she's going to cook lunch and wow that to play with my younger sister. So
don't worry. We will only say if you have something relevant to the lesson. Okay, so don't worry if it's not to do with the lesson. So natural disasters is our case study. We're going to look at slightly more information to do with wildfires and wildfires in California. So again, we'll read through some of these and make some notes if you are unsure of the words. We'll have a little bit more of a look at natural disasters. I'll choose some of you to read paragraphs. California fires are raging. Get the facts on wildfires. California fires are raging. Get the facts on wildfires. As seasonal winds drive flames across the strait, here's what you need to know about how these fires start and how they're put out. So, we'll read up to how wildfires start. Okay, I'll choose some of you to read the introduction, and then I'll read the how fires start, and we can see. First reader, strong winds are fueling fires across California. So first reader, I'll choose some of you. Let's go for Any volunteers for reading this first paragraph here? Strong winds are fueling.
Yes, me.
Okay, Leanne, first paragraph for me, please. Thank you.
Strong winds are fueling fires across California, with the Kincaid Fire in Sonoma County near San Francisco among the fiercest reports. Fiercest. Eyewitnesses told local news that the fire was racing through vineyards and across, setting homes ablaze and forcing residents to flee.
Thank you, well read. Next reader, just second paragraph here. I think Quack Tai, did you raise your hand? Can you read the second paragraph? Quack Tai, please.
In Southern California, the Tick Fire near Santa Clarita is burning out of control, CNN reports, and it's moving quickly as seasonal wind gusts across the state.
Good. Seasonal winds gust across the state. So the wind causes the fires to move a lot faster. Teluk, you can read the third one for me. Thank you. California.
Okay. In southern California's most destructive
Yeah. Are you still there, Teluk? Is your connection not too good?
Yeah. Okay.
Okay, you can try one more time for me. California's
most destructive fires often occur in the autumn, when vegetation has had a long, hot, dry summer to desiccate into perfect timber, and when annual offshore winds whip onshore.
Good. Let's check that word. Desiccate. All the moisture is removed. All the water is removed when you desiccate something. Remove all the moisture, water. When vegetation has had the long, hot, dry summer to desiccate into perfect tinder. So this is what burns very easily. I can burn this very easily because it's so dry. California's worst fires over the past few years. Next reader, let's have. Could I have Binkoa? Are you there? Binkoa, could you do this one? California's worst fires. No, Binkoa, are you there? No, okay. Let's choose a different one. Koi, could you read this one? California's worst fires.
California's worst fires over the past few years, including the Camp Fire and 2017 Thomas Fire, started when power lines sparked flames in dry glasses. The Los Angeles Times reports that local power lines were still live near the ignition point of the Kincaid Fire, which may have sparked the conflagration.
Good. Conflagration is another good word to use. May have started the conflagration. Very large fire. Conflagration. Very large fire. Conflagration. Good word to use. Firefighters will battle the blazes through the weekend as fire officials expect them to grow. So these are the problems with California's wildfires. How do they start? Wildfires can burn millions of acres of land at rapid speed and consume everything. Trees, homes, humans, and their paths. These rolling flames travel up to 14 miles an hour, which converts to about a 4-minute mile pace and can overtake the average human in minutes. So it's difficult to escape these wildfires. It's increased significantly in the last 2 decades. An average of 72,000 wildfires cleared an average of 7 million acres in the US since 2000, and double the number of acres scorched by wildfires in the 1990s. The largest wildfire season was in 2015. Wildfires burned more than 10 million acres of land. So it's a big problem that they've had. So I just wanted to show you that this is an example of a case study. This is to give you some ideas. Let's look at the first 5 pictures in our slideshow to explain, to give you a bit of a visual aid for these fires. Firefighters battle the Woolsey fire as it burns through Malibu, California. So California is the worst place hit. Embers fall from burning palms and the sun is obscured. You can't see the sun by smoke as flames close in a house trapped in the Woolsey fire in Malibu, California. Mayor of Malibu and firefighter Rick surveys a burning house caught in the Woolsey fire. Chimneys were all that remained of the residents gutted by fire in Paradise. The bodies of 5 people were found in a car on Friday as authorities assessed the damage. So the town is completely destroyed by this wildfire. A burned pickup truck rests on Pearson Road in Paradise, California on November 10th. Not much is left in Paradise after a ferocious, dangerous wildfire roared through the Northern Californian town. So these can be very destructive and can cause a lot of damage, our wildfires. So we've looked at our case study. You can look in further detail at this as I want to explain your project or your mini project that I want you to do personally by yourself. So you're going to do a natural disaster mini project. I'm going to give you this week to do it, and I want you to research a natural disaster case study like what you can find on this website or any website you can choose. I want you to choose one natural disaster that has happened in history. It can be anything that has happened from around the world. And I want you to put the information about the natural disaster into a poster where you can include the causes of the disaster. So you can say how it started, what happened, maybe a little bit of the science like we've been looking at, how it's caused. And I want you to also write about the effects and the lasting impact on that place. So you can, for example, if you were doing Californian wildfires, you could describe the effects of the wildfires, maybe include a couple of pictures and describe the pictures also. But I want you to create your poster on your computer, so you can do it in a Word document. You can include pictures and information, or you can do it into a PowerPoint and include pictures and information. You can think about your design and how to present your natural disasters. So
What's
any
the
natural
maximum number of slides in PowerPoint?
Maximum number of slides. I think we can say around about, you can say 4 or 5 slides because we don't want it to be really long. 4 or 5 slides.
Yeah, we must be that long.
Yeah, so 4 or 5 slides. You can maybe do a slide on causes, you could do a slide on effects, and you can do a slide on lasting impact. So these are your PowerPoints, and then I'll give you until Friday. In Friday's lesson this week, we're going to choose some of your PowerPoints or some of your Word documents. I want you to, you can share your screen on your computer, and then you can go through, describe your natural disaster, and we can get feedback from the class to see about your project and about your presentation. So again, not really long, doesn't have to be a really long presentation. If it's a Word document, you can just do 1 page, causes, effects, lasting impact. If it's a PowerPoint, 4 or 5 slides, and we'll get some of you to present your ideas on Friday. Does that make sense?
Yes.
Good. Any questions about that? No, we will understand that. Good. So I'll give you this week to do it. Make it look nice, make it look as good as you can, and then we can present our ideas on Friday. So get prepared for that, make a note of that, and I'll put it on EPC as well so you can see this. I'll put this on EPC so you can see exactly what you need to do. I want to give you some help for this as well. So I'm going to give you, this is mini project ideas and information. So we can watch a natural disaster video that describes the most famous disasters. So this is to give you some inspiration. You can see some of the disasters that have happened in the past. You can use this information to help when designing your own poster. So we'll watch our video. Think about what makes it interesting, how to keep an audience or an observer engaged when speaking and giving presentations online. So a natural disaster video. I might have to copy and paste and put it in the chat because my sound might not work.
Our planet is a living planet and the only known celestial body to have both a fully functioning climate system and active plate tectonics. But all that moving and shaking makes the Earth a potentially dangerous place to...
Do we have sound?
Yes.
You can hear?
Yeah. I can.
Good. Okay, let's play our video to give you some ideas.
Call home. And natural disasters are an unfortunate but inevitable part of life for any species that calls our blue marble home. Evolving around 100,000 years ago, modern man has barely been around for but a blink of an eye in the Earth's history. And while we've been spared some of the greatest catastrophes to ever rock the planet, we faced our share of natural disasters. Hello and welcome to another episode of the Infographic Show. Today we're taking a look at the worst natural disasters in human history. 10. With humans first settling large river valleys, floods have been one of our persistent woes throughout human history. Yet few floods have ever matched the devastation of the Central China flood, occurring across the span of Middle China in 1931, preceded by an abnormally heavy monsoon season that resulted in 9 cyclones in 1 month just prior to the flood. China was alternatively rocked by heavy drought and then extreme rainfall. This sudden rainfall led to the Yangtze, Yellow, and Huai rivers bursting their banks and flooding Central China, killing millions of people and causing enormous property damage. Famous as the deadliest flood of the 20th century, the Central China flood killed an estimated 3.7 to 4 million people. 9. Egypt-Syria earthquake of 1202. The deadliest earthquake in recorded history. 13th century Egypt and Syria were rocked by a megaquake that led to a cascading cycle of disasters, such as floods, tsunamis, and then famine from devastated crops. Thought to have been caused by a geologic shift under the Dead Sea, the earthquake created a tsunami which led to extreme flooding. All in all, the string of disasters left over 1.1 million people dead in the region. 8. North Korea's arduous march. North Korea has a long history of rebranding its natural disasters, and few in its history were more devastating than the arduous march that began in 1994 and lasted for 4 years, nearly half a decade in length. The arduous march started as a famine, which was quickly exacerbated by a series of natural disasters. With its roots in ineffective government and the collapse of North Korea's patron state, the Soviet Union, natural disasters intensified the effects of the resulting famines, leading to over 500,000 deaths. Recently, North Korea has warned its citizens that another arduous march is incoming, and the world may soon see a repeat of one of the worst disasters in modern history. 7. Great Bengal Famine of 1770. Often at the whim of a precocious Mother Nature, humanity is no stranger to famines. Ruled by the British East India Company at the time, the Great Bengal Famine of 1770 struck territories in modern West Bengal, Bangladesh, Assam, Odisha, Bihar, and Jharkhand. A shortfall of crops in 1768 was a precursor to the disaster, but it was at the time nothing out of the ordinary. However, after the failure of the annual southeast monsoon, a severe drought gripped the area and crops failed across the region. Initial reports of starvation were largely ignored by the East India Company until mass starvation struck in 1770. A series of disease outbreaks and mismanagement by the British ultimately resulted in over 10 million deaths among the native population. 6. Chinese drought of 1876. Drought inevitably leads to famine, and no drought was deadlier than that which gripped China in 1876. A 3-year drought brought on by failure of regional monsoons devastated crops across across the nation, leading to between 9 to 13 million deaths from starvation. Perhaps feeling guilty over their historical inaction in the face of catastrophe, the British actually organized a global relief effort organized by British missionary Timothy Richard, who established the Shandong Famine Relief Committee. Richard kept a detailed diary of the catastrophe and highlighted people eating the material of their own houses, selling wives and daughters in a bid to stay alive, and even dead children being boiled and eaten. 5. The 1918 flu pandemic. Disease is one of humanity's oldest foes, and few are more persistent than the seasonal flu. Yet taking hold amidst the destruction brought on by World War I, the 1918 flu pandemic would be the deadliest in history, infecting 500 million people and killing between 20 and 50 million of them. Yet the strain of flu responsible was no more virulent or deadly than the modern flu, and instead became deadly by ravaging a world population suffering from poor hygiene, concentrations of war casualty hospitals, and poor nutrition, all side effects of the First World War. First observed in Europe, it's unknown where exactly the flu started, but it quickly made its way around the world. In America alone, it dropped the life expectancy by a whopping 12 years. 4. Yellow River Flood. China is home to some of the world's mightiest rivers, and as a result is prone to the most catastrophic floods in history. Due to the elevated nature of the Yellow River, which runs along natural dikes that raise it above the plains that surround it, it is one of the most flood-prone rivers on Earth, a fact well known by the local Chinese, who for millennia reinforced the banks of the rivers with artificial dikes. Yet in 1887, after days of extremely heavy flooding, the Yellow River burst its banks, flooding large portions of eastern China and covering an estimated 50,000 square miles. The initial floods left 2 million people homeless, and the resultant famine and lack of essentials led to the death of an estimated 900,000 people. 3. 1556 Shaanxi earthquake. Drought, famine, and floods. It seems China really has it all when it comes to the worst of the worst. One of the deadliest earthquakes on record, the 1556 Shaanxi earthquake, struck on the morning of January 23rd during the Ming Dynasty. An area of 520 miles wide was completely flattened by the tremors, and an estimated 830,000 people died, with 60% of the region's population dying and absolute destruction in urban areas. The total cost of the earthquake is all but impossible to calculate. 2. 1970 Bola cyclone. It seems Asia is a rather unkind place to live, but thankfully we can leave China alone for the moment. Striking East Pakistan in India's West Bengal on November 12, 1970, the 1970 Bola cyclone is one of the worst storms the region has ever seen, and the deadliest storm in recorded history. Due to a severely inadequate early warning system in Pakistan, the total death toll is estimated to be as high as 500,000. Sadly, just after a duo of destructive cyclones in 1960, the Pakistan government had contacted the Americans for assistance in developing a national early warning system to help people evacuate. After a detailed study and subsequent report granted to Pakistani authorities by the director of America's National Hurricane Center, it was revealed that the Pakistani government did not carry out most of the recommendations given to them, leading to 1970's staggering death toll. 1. 576 earthquake of Antioch, striking ancient Syria. The earthquake of 576 AD in Antioch devastated the Byzantine Empire and all but completely leveled the city. The earthquake struck without warning on a morning between May 20th through the 29th and killed an estimated 250,000 people. Based on the severity of the destruction, scientists estimate that the earthquake was between a category 8 and 9 on the Mercalli intensity scale. The survivors of the initial earthquake then faced a massive fire which consumed all of the remaining standing buildings, nearly wiping out the city in its entirety. Emperor Justin I was reportedly so devastated by the news of the death toll that he entered the church in Constantinople without any of his holy symbols in an act of humility before God. A massive relief and rebuilding effort would see the city restored, but its inhabitants would forever be haunted by the death of 250,000 people. For as long as we remain on the earth, humanity will continue continue to see its fair share of natural disasters. Yet modern improvements in warning and alerting systems and international cooperation between nations to coordinate relief efforts has seen death tolls dramatically lower. Despite this, though, it's certain that humanity still lives on a dangerous world. And with bubbling supervolcanoes slumbering under Italy and Yellowstone in North America, the real worst natural disaster in history may not lie in our past, but in our immediate future, perhaps even as early as tomorrow. What's the worst natural disaster you've ever heard of? Have you ever been in a natural disaster? Let us know in the comments. Also, be sure to check.
Okay, so some examples of natural disasters there. So you've got some ideas. You could choose one from the video, or you can do your own research. From the video, has anyone experienced any natural disasters or anyone experienced an earthquake personally? Or have there been any in Vietnam that you can think of? Any of these types?
No.
No.
You don't think so? No, there hasn't been? Okay, so for your project, I'm just thinking, yeah, you can choose one natural disaster that has happened, or to make it slightly more interesting also, you could even, you have a choice of introducing your own fictional natural disaster. If you want, you can pretend that a supervolcano or an earthquake or any such thing describe what caused it, how people reacted, and in your own words, your own future natural disaster that has not yet happened. You can even include that if you want for your ideas, so it can be a fictional one, it can be anywhere in the world for your PowerPoint. That's also an option. Or even, if you want to, you could even talk about the current situation that's happening, where you can also talk about virus, coronavirus. You can give people the cause, you can give the effect, how to help people, what to do in this situation. You can create your own poster on that as well. So there's many options you can do for your mini project. So, does everyone understand what they need to do for Friday?
Yes.
Good. Do we have any questions about it? If you're sure, you can ask me anything. Okay. Well, you can give me a message if you do have any questions or anything like that, and I can respond to you. So, good. Thank you, guys. I will see you again. See you tomorrow. We can move on from our topic. We'll move on to the next topic.
I have a question.
Yeah, question?
Does it really have to be a natural disaster? I mean, can it be a artificial disaster?
Yeah, if you want to, you can choose an artificial disaster. As long as you describe it, give its causes, effects, and how people have reacted to it.
Chernobyl!
Yeah, if you want to, you can describe that. You can do your own case study. So, thank you, guys. I'll see you again. Goodbye. See you tomorrow. Have a good day.
Hey.
Bye-bye.
Goodbye.
Bye-bye.
Bye.
See you later.
Goodbye.
Bye-bye.
Good morning, each and everyone. Today is Tuesday. Okay, so we're going to have our class, right? So I'm going to find our, okay, wait. Today is March 24, 2020. Our lesson for today is all about probability. All right. I guess we just learned this last time, right? Way back August. I think you have already idea what is about probability. Okay. So today's lesson is about probability that an outcome does not happen. All right. An outcome does not happen. Outcome means the result does not happen. Okay. All right. Our objective for today, to use probability of an outcome of an event occurring to find the probability it will not occur. occur. Can you tell me what is occur or occurring? What do you mean? Happen. Yes, happen. Happening or happen. Use probability of an outcome of an event happening to find the probability it will not happen. All right. So now, are you familiar with rock paper scissors, right?
Yes.
Yeah, very familiar.
I think it's 1 out of 3 because you have rock, you have paper, you have scissors.
Yes, this is
3 probabilities.
This is really illustrates or give us idea about probability, because there are 3 results. If we are going to do this game, the scissor cuts the paper, so scissor beats the paper, and the paper rubs the stone. So the paper is the winner, and then the stone blunts the scissor. So really, this is a fair game. And it says here that this game is equally likely. What do we mean by equally likely? Equally likely means this it is fair, equally fair, because there are 3 outcomes or results. Each one has probability of 1 over 3. So there is no bias there. It means to say it's only fair game. All right. Nobody can say, "Oh, teacher, you are so biased. You choose this one. You like this one." Okay. So bias means you are not fair, right? So probability this game is equally likely, right? So what do we mean by probability? Before we define this probability, all right, it describes how likely it is that an event will happen, right? So for example, you have here a set of marbles, with different colors. We have yellow and purple. So it means to say, you can say that certain, it means to say 100% or sure, you are sure that you can choose a marble on this setting. And then another one is, it's likely only to choose purple. When you say likely, more purple you can choose in that setting. And then when we say unlikely, only few or least number of items that you can see on the setting. So you can see they're unlikely to choose yellow. But how many yellow are there?
2.
Only 2. All right. When you say it's impossible to choose green, why is it that it's impossible to choose green?
Because there's no green.
Yeah, because there's no green, so impossible. All right, so it's impossible. Okay, now we have here, if the probability of an outcome of an event is P, then the probability that it does not happen is 1 minus P. All right, so it means to say 1 minus P equivalent to fraction, decimals, and percentage, right? And percent, right? So just like this example, throw a dice and get a 6. So what is the probability of getting a 6 in a die when you throw a dice? So there is, how many 6 are there in the set of dice?
1.
Only 1. So 1 out of 6. So it is equally likely outcomes, because the dice is fair enough to find out results, right? If you have 6 numbers there is no 2 1s, no 2 2s, no 2 3s. Everyone has 1, okay? Everyone wants 1 number there. So there are 6 spaces, so therefore it is fair enough, equally likely outcomes, right? Well, when we say a seed will germinate, so the probability of having this seed germinate is 0.75. When you experiment, you will have 0.75 results. And then we'll say it will rain tomorrow. Oh, you'll see. Today is like having like a cold weather, or maybe there is a 10% raining tomorrow. So you can say like that. So, but if you look at the results here, the red marks here, you can see probability in a range, and they are in different forms, right? So the first one is, what form is that? What form is in the first example there? Throw a dice and get 1/6.
Fraction.
It's a fraction.
Fraction.
And on the second one is in
decimal.
Decimal. And the last one and the third one is percent.
Percent.
That means to say probability, you can give the result as fraction, as decimal, or as percent, like this. Okay, I'll just give you example like this. So you will have like impossible, 0, unlikely, even chance, likely, certain. So we just learned this one. As long as it's 0 to 1. So those numbers between 0 to 1 are fractions, are decimals, or in percentage, right? So you can see below there, you can see that 1/4 unlikely is the same with 0.25, or in percentage, it is 25%. Yeah. So do you have any question? Do you have any question with this? No.
No, it's just no.
Is
It's
it
just a lot of
understandable?
families.
Right? All right. Okay. Another example here. It's 0 to live forever, right? It's impossible to live forever, right? And winning the lottery, unlikely. Why unlikely? Why is it unlikely to win a lottery?
There are way too much resources.
Because there are so many slots and
so many
way too much
slots, and they will can come at a random chance. So there's
no
way that you.
Yeah, and only a few percent, or only few fraction you can win a lottery. Okay, when we say even chance, the coin there, why is it even chance?
It's equal.
All right, equal. It means to say it is like 1 head and 1 tail, only 2 results, and it is fair enough. Say that they are even, they are the same. All right. Now, becoming a good student, why is it likely?
Unlikely, teacher.
Unlikely.
Unlikely.
Yeah.
Unlikely.
Becoming a good student is likely. Why? Because there's a lot of chances. A lot of chances that a student will become good, right? Okay? It's just a change of mind. For example, before you are not really so focused. Now you will be focused. You will become good. So everything that you just study will come out, and then you'll understand, right? Okay, how about when we say the sun will rise again? Why is it certain?
Why the sun? It's the sun.
Every day.
So sun is rising every day, right? So will rise every day. So it is certain. It is important. It is possible that every day the sun will rise. All right. Can you give me a situation, an event about this? You can choose. Is it impossible, like unlikely, even chance, likely, certain? Okay. Just give me a few students can give me samples. Who wants to give me first?
Example for certain.
Yes. Can you give example? Yeah.
Of certain.
What?
I'll give example of certain.
Yes, certain. What example? It is certain.
If you haven't breathed in a long time, you will die.
Yeah. If you haven't eat for a long time, you will surely die, right? Yeah, correct.
Yeah.
Of course, because we live by food. If we don't eat, we die. Right? Who else? Who else? How about impossible? Impossible. Yes, Min? That? Kan. Namkan. Yes, Namkan, you're raising your hand.
Possible.
Impossible. Okay, give me a situation wherein it is impossible.
Teacher, Nick is handsome.
Oh.
Nice one. It's true.
Oh.
It's actually true.
Oh, no. Okay. How about unlikely? Can you give me an unlikely event? Unlikely. Can you think of unlikely event? Yes. Koy Nguyen. Koy Nguyen. Unlikely. What?
I will take a nap in the noon.
All right. In the news.
In the noon.
In noon. You nap at noon. So it's unlikely, or not really so much time you nap. Only few hours you nap. So that means for the whole day, 24 hours, only few hours you be napping. All right. Very good. All right. Even chance. Last. How about even chance? Who can give me an event in an even chance? Yes, Pamdang Tai. Yes, Pamdang Tai.
Yes.
Yes.
I
Even
think
chance.
Can ride a bike, a motorbike when you are under 18.
Oh, riding in a motorbike under 18. So if you just say, if you're getting 18, that's the time you ride a bike. And if you're not 18 before 18, you cannot ride bike. All right. All right. Now it says here, if you throw an ordinary 6-sided dice, what is the probability of getting a 7?
Impossible.
Impossible.
Oh, there is no 7 dice.
Yeah, there is no 7 in the dice. All right. What is the probability of getting less than 7?
Certain.
Okay, so one. Okay, 100%. All right. Next, can you answer this? Give me the answers here. Which letter is the spinner least likely to land on? Is it A, B, C, or D? Least likely.
D.
Letter B or letter D? D. Yes, letter D. How about number 2? Which number is the spinner least likely to land on?
1.
1, because only one. Only one. All right. How about letter number 3? Which number is the spinner most likely to land on? What? 1, 2. All right.
3.
Most likely. So 3. How many 3s?
3.
3.
All right. Which number 4? Number 4. Which letter
C
is the spinner most likely to land on? Letter C. Why letter C? How many C are there here? 3. All right. So it's most likely to land on. All right. How about number 5? Which letter is the spinner least likely to land on?
D.
I, B, C, or D?
D.
Okay, D. List. Okay, list. All right, list. How about number 6? Which 2 letters is the spinner equally likely to land on? A. All right, it's A. Let's see if your answers are all correct. Let's check. All right. Oh, why is it C and D?
Equally likely.
So, which 2 letters is the spinner equally likely to land on? All right, there are 2 letters. So, it's C and D. Why C and D?
Because they are equal in number.
Yeah, because C, how many C's are there?
C is 1. D is
1 C. How many D?
1.
1. All right. Look at letter B. Letter B has 2. Letter A has 3. So only two letters there has one number, one letter, right? Okay, I'll just add more because some you just you haven't answered completely, or it means to say you're not perfect. You didn't make it perfect. All right, another one, number 7. Which number is the spinner most likely to land on in this wheel? 1, 2, 3, or 4? Remember, most likely.
3.
3.
3. All right. How many trees are there? There in
4.
the 4. All right. So number 8. Which number is the spinner most likely to land on?
3.
3 also. All right. So in number 9, which letter in the spinner least likely to land on? Is it A, B, C, or D? Number 9.
B.
So, least likely, means say the smallest number of letters there. Is it A, B, C, or D?
B, B, B.
All right. How many A?
3.
3. How many B? How many B? 2. How many C? 4.
4.
How many D?
4, 2.
All right. What letter is least likely? Letter?
B.
B.
Letter B.
All right. Letter B. Number 10. Which number is the spinner least likely to land on? Least. All right. How many 1?
3.
3. What?
2.
3 or
2.
2? How many 2?
Least cơ mà.
3.
Yeah, least.
3.
Okay.
3,
4.
2.
Okay, 4. 4. How many
4,
3?
2. No.
Yes. Number 10. Number
1.
10. All right. 1, 3. And number, how many 4s?
3, 4.
3. So,
3,
what is
4.
the least number likely to land on? The answer is it
3,
1
3.
or 3? Okay, number the 3. All right. Next, number 11. We're now on number 11. Which number? Oh, sorry. Which letter is the spinner most likely to land on?
D.
Letter D.
No. Likely.
A.
No,
Most likely. A lot of letters.
B.
B. So B. The answer is B. It's obvious. You can see 4 B's. All right. Number 12. Which 2 numbers is the spinner equally likely to land on? 2 numbers.
1 and 4.
1 and
4.
All right.
1
1
and
and
4.
4. Right. Why 1 and 4? How many 1s?
3.
3. How many
3.
4?
3.
Okay.
3.
How about 2? How many 2?
1.
1. How many 3?
1.
2.
2. All right. So the answer is 1 and 4. All right. Let's see. All right. That's the answer. So number 7, 3. Number 8, 3. Number 9, B. Number 10, 3. Number 11, B. Number 12, 1 and 4. Okay. Let's see this. Probability of getting a 7 is?
0.
0. There's no 7 there. So that is the question a while ago. All right. So who can answer this question? First question. Muklin, you are the first one that I saw in
Nani?
In a cam when I open my cam. All right. Ready? Muklin, ready?
Yes.
Go. Okay.
Yes.
Jake estimates that the probability that its batch will be early is 0.05, and the probability that it will be more than 5 minutes late is 0.3. What is the probability that it will not be early? That it will not be early. What is the probability?
0.95.
What?
0.95.
Nguklin, what's your answer?
0. Wait, teacher, I must. 0.95.
0.95. I heard, is that who said that one a while ago before Nguklin? That Koy Nguyen. Okay. All right. So your answer is 0.95. How did you get 0.95?
I take 1 minus 0.05.
All right. So let's see. I will type here 0.95% or what? No, no percent.
No percent.
All right, let's check. Let's check. 1, 2, 3. All right, very good. All right, next. What, Koing Lian, Koing Lian, what is the probability that it will not be more than 5 minutes late?
0.7.
0.7. How did you get 0.7?
I take 1 minus 0.3.
All right, you take 1 minus 0.3 is 0.7. Let's check. 0.7. All right, 0.7. Let's check. 1, 2, 3. Okay, very good. Correct.
Yeah.
All right, next. Next question. Kwan,
Yes.
are you ready? Are you ready for the next question, Kwan?
Yes.
Okay, ready. Kwan, a survey of the makes of cars using particular road gave this result. So you have Vox Sota, we have 12%. Toy Wagon is 8%. Hyundai is 7%. Yusan is 11%. Question number A, or question letter A. 1. Harsha says it must be wrong because the probabilities do not add up to 100%. Can you explain why she's wrong?
I think she's wrong because first of all, there could be not a lot of cars on the road. So basically, it cannot be always 100% cars.
Oh, so you are saying that if you are going to add all the percentage here, it will not be 100%?
Yes, it cannot be 100% cars.
All right, cannot be 100%? Yeah? Uh-huh.
Yeah.
All right, very good. Okay, who else? Who can explain why Harsha is wrong? He said that, oh, the probabilities do not add up to 100%. Must be wrong. So it says that she is wrong. All right? Who can answer? Viet An, are you there? Yeah, just try to call. Okay.
Yes.
Okay. Why is it she's wrong? We have to explain why she is wrong. Harsha says it must be wrong because the probability do not add up to 100. What do you think? Okay. What do you think? Okay, can we find help to Natlin? Natlin, you're there?
What?
Yes. Why is it wrong? All right. So,
because there are other cars on the road too.
Yeah. In the other cars, what? Yeah, you have idea.
There are other car brands on the road too, not just these.
Oh, really? Okay, that's a little bit, not little, but a big idea. You are saying that some of the cars, the model of the cars are not yet presented there, right? Yeah, some of the cars are not yet there because only Vox Sota, Toy Wagon, Hyundai, Yusan, and some of the other cars are not yet there. Because when you add 12 plus 8 plus 7 plus 11, it's only how many percent? If you are going to add 12 plus 8 plus 7 plus 11%.
38.
38 only. So it means to say our reason here, the least, all right, the least, what shall we put here? The least does not what? Does not include, all right, include all possible make. All right, possible makes. Is it correct?
Yes.
Do you think that will be good enough for our reason? Because on the list there, does not include all possible makes. Only Bixota, Toywagen, Inday, Yusan are there. So let's check if our answers are correct. All right, very good. Okay, so I'll just get your idea only, and I'll be the one summarizing it. Right? Very good. Now, can I ask? Can I ask Dui Bao? Tang Tran Dui Bao?
Yeah.
All right. Okay. How about in letter B, 1 on I? Not a toy wagon. Not a toy wagon. How many percent?
92%.
Why did you say 92%?
Because 100 minus 8%.
All right, 92%. So let's put here 92%. Okay, like that. All right, let's see. Check it first. Wow, very good. Thank you. All right, let's see. Gatoy, are you there? Gatoy? Yes.
Her microphone is broken.
Okay. Tran Tuan Long, are you there? Tran Tuan Long? Hello, Tran Tuan Long, are you there?
Hello, hello.
Yes, yes. Okay. Now, how about two eyes there? Oh? Not an Ninday. What is the answer there?
93%.
Not an Inday. Not an Inday. Number 2. Two eyes. So what should be the answer there? Ninday. How many Ninday are there in the
7%.
screen? Okay, 7%. So not an Inday. Not an Inday.
Not a Nindai is 93%.
93%. All right, let's check. All right, very good. Okay, you're good. Okay, next. 3. 3 eyes. Let's see. Pong, are you there, Pong? Pong?
Pong.
All right, Pong. Okay. Or not you. Pong. Pong? Pong, are you there, Pong?
Huy Phong.
Pong, Pong.
No, he's not Pong.
Okay, P-H-O-N-G. Pong.
Phong.
Pang, Pang. Okay, Pong.
Pang, yes, Pang.
Yeah, Pang. Okay, Pang.
Pang.
All right, Pang. Are you there, Pang?
Yes, now Pong has a new name. Pang.
Okay, what's the answer? Not a toy wagon or Ninday.
85%.
85%. Why? Why you say 85%?
Oh my God.
Yeah.
85%.
100% minus 8% minus 7%.
Ah, okay. Because you are there, you have there in toy wagon 8% and Ninday have 7%. So you have 100% minus 8 minus 7. So the answer is 85%. All right, let's check. 1, 2, 3. Wow, very good. Okay, that's correct. Okay, next. Can I ask Kuktai? Kuktai.
Yes.
Kuktai. All right, Kuktai, are you there? All right. So next question for Kuktai. All right, if you throw, if 3 dice, okay, you can see there 3 dice. The probability of getting 3 sixes is 0.5%. The probability of getting no sixes is 57.9%. Find the probability of getting A, fewer than 3 sixes. Fewer than 3 sixes.
Okay.
Fewer.
99.5.
How much?
99.5%.
99.5%. How did you get 99.5%? Okay, let's check. 99.5%.
I might be wrong though. I don't know. They say the probability of getting 3 sixes is wait, is 0.5. So
Yeah.
it means that, for example, you get a double 6, it isn't a 3/6. So basically, it also counts.
Right. So it means to say you just what? You just subtract.
So I have to get the probability of getting 3/6 and divide it by 100%.
Divide by 100%. Okay. Your answer. Let's check first your answer, and because we are going to find out why is it correct. Okay. Let's check. 1, 2, 3. Good. Okay. That's good. That's correct. Can you explain again? Who can explain again? Why is it 99.5?
You need me to explain again?
Yes.
Okay. Because the probability of because they said fewer at 3/6.
Yes.
So the probability, so we have to exclude the chance of getting 3/6.
Yes. So 0.5, we will exclude that one. Only those getting 3/6. Yeah. Because it's fewer than 3/6. So 100 minus
100 minus 0.5.
0.5. Yeah, correct. That's correct. All right, next. Who's next? Can I ask Uyen? Uyen, are you there? Uyen? Yes, Uyen. All right. At least 1/6. Only 1/6. At least 1/6. Uyen is there? Are you there, Uyen? Ha Uyen. Ha Uyen. Yeah? Ha Uyen? Or maybe I'll just
Hey, I'm here.
all right, okay. Ha Uyen. So what is the at least 1/6? Only 1/6.
Only 1/6?
Yeah, what is the probability?
I think 42.1.
All right, let's see. 42 point what?
1.
42.1. Is that
Percent.
Uyen, right? Uyen? Yeah?
Yeah.
Percent. Okay. Uyen said 42.1%.
That was
yeah?
me. OMG.
Oh, it's
It
not
was
you.
Gobling.
Oh, maybe you have a different answer. Let's see. Okay, what's your answer, Uyen? All right.
Okay.
Yeah.
No,
Your answer is?
but I don't know. But I don't know how to explain.
All right. So
I have
can you give me the answer? What is
I know the
probability?
answer, but
Yeah.
I know the answer, but I don't know
Not sure.
how to explain. But I'm not understand it.
Okay. So what's your answer? I will put it here if you say your answer.
But I can't copy Ngọc answer.
You can copy, but you have that is your answer too, right? 42.
Yeah, 42.1.
All right. Okay, 42.1. Okay, now can I ask first, Nguklin, why you have 42.1?
I take 100% minus 57.9% because
Yes.
they're getting no 6 is 55.9%.
All right, so you just subtract.
Yes.
Just subtract. Okay, how about Uyen?
Yeah.
She cannot explain it, but a little bit explanation. How did you get the 42.1?
So getting the probability of getting no 6 is 57.9%. So
Yeah.
I take 100%
Okay.
subtracted by 57.9. So I have 42.1.
Very good. That's the correct answer, right? Let's see if we really have correct answer. Yeah, 42.1%. All right. Okay. All right. It says here. Okay. Probability also is equal to events over number of outcomes. Remember that when we find the probability, it will be also fraction, right? So like for example, this wheel here, find the probability of spinning yellow. So you have to count how many yellow are there. So there are 3 yellows, and the total number of possible outcomes, how many of them? There are 8, right? 1, 2, 3, 4, 5, 6, 7, 8. All right, there are 8. So the probability of spinning yellow is 3 over 8, or we can say it is 3 out of 8, right? Okay, so we can use fraction as our ratio, our probability, right? Okay, let's check another example here. Oh, not yet example, but it says here that the probability of an event denoted by, or it's written as P, E, is the likelihood of that event occurring. So for example, an event, there's an event. So P, open and close parenthesis event, right? So it says here that the number of ways it can happen and the total number of possible outcomes. All right, I will give you example, but we're going to answer it. Okay, Dang Tai, can you answer the first one here, the example here? Dang Tai, hello? Yeah? Sam, Dang Tai?
Yeah.
All right, okay. How about this? If you were to roll the dice 1 time, what is the probability it will land on a 2? Is it 2 out of 6?
1 out of 6.
1 out of 6. 1 out of 6.
1 out of 6. Why?
Yeah.
Because there's only
Well,
one
1 out of 6.
number
1 out of 6
2
is
on
there.
a dice.
6.
If you roll it 1 time,
In the dice we have
probably
3, 4, 5,
it will
6,
land on 2 is 1 out of 6 because a die has
Yeah.
Right.
Okay, let's check.
Sides.
Let's check. Yes, correct. Let's check. Oh, very good. So, how many 2 are there in dice?
Just one.
Only
One only.
Okay, there
Yeah.
are six numbers there. So 1 out of 6. Okay, how about Min? Min, are you there, Min? All right, Min.
Not me.
Okay, okay, Min. Okay. All right, this is your question, Min. If you were to roll the dice 1 time, what is the probability it will not land on a 3? It will not land on a 3.
Out of 6.
What?
5 out of 6.
5 out of 6 or 1 out of 2 or 1 out of 6? So your answer is 5 out of 6. Let's see.
Yeah.
Yeah, correct. Because there are 5. It's not 3. All right, it's not 3. So can I ask another student? Can I ask Zhang? Zhang, are you there? Yeah. Zhang, yeah, Zhang. D-U-N-G. Zhang. Okay. Okay, ready? Zhang, go. If you were to select, okay, it's not opening his speaker. Okay, and still mute. Okay, if you were to select one shape at random from the array, what is the probability it will be a circle? Gyatui, can you help Zhang? Gyatui, your speaker, yeah. Nguyen Chuan. Nguyen Chuan. Yes.
Can I answer the question?
All right, sure. Nguyen, is that you? Okay.
Okay.
So what's
Okay,
the answer?
so the total of all of the shape is 16.
All
so
right.
in this picture, they are 1, 2, 3, 4, 5, 6, 6 circles.
Six
out of 16.
16. All right. 6 out of 16. Let's check.
Yeah.
Yeah. Okay. Next. Who can answer this? Again. Can I ask? All right. Yeah. Is that Luke? Are you there, Luke?
Yeah.
Okay. Look. If you were to select one shape at random from the array, what shape do you have the greatest probability of selecting?
Rhombus.
Rhombus.
Is it rhombus?
Because
Uncomfortable.
yes.
A rhombus? Or what we call it is a diamond, all right?
Rhombus.
Okay.
So rhombus or diamond. Okay. So let's check if Luke is correct. Yeah. Good. Good. That's good. All right. Okay. Let's this one. Check this one. How about this? Okay. The spinner at the right is spun once. Determine the probability of its event. So what is the probability of having F, letter F there? So you have to count how many F there. How many F? How many F's there in that circle
One.
there?
One.
Only one.
One.
How many total? How many total?
10.
10. So
10.
1 over
1 out of
10.
10.
Or we can write this in decimal. What's this in decimal?
0.1.
0.1 in percentage. How many? How much? In percentage?
10.
10%. So it will say 1 out of 10, 0.1 or 10%. How about letter the next one, P, or probability of D or G? D or G? D or G?
1 out
How
of
many?
5.
1 out of 5. Why? Why did you say 1 out of 5? How many D?
1.
Plus 1. How many G?
1.
So how many total?
2.
2. Okay. How many total of the outcome here?
10.
10. So
10.
2 out
1 out
of
of 5.
10 or 1 over 5 in decimal?
0.2.
0.2 in percentage?
20%.
20%. Okay. Next. The probability of having a vowel. Vowel.
What is
Do you know?
that?
Do you know what is a vowel?
Yes.
Yes. Okay. How many vowels are there here in this circle, in this wheel?
3.
3.
3 vowels.
Okay. A, E, I. All right. There are 3. So 3 out of 10. All right. 3 out of 10 or 0.3 or
30%.
30%. Very good. All right. So, okay, we will continue this lesson because we are running out of time. Okay, I want you to continue answering your course book on exercise 15.1 on page 149, and also your this one, the practice book on page 74 to 75. So what we have learned today, we have the rock, paper, scissors, right? The first one, the first lesson, we have rock, paper, scissors. It is a game wherein it is equally likely because there are 3 outcomes, right? So each one has a probability of 1 over 3. Next is the meaning of probability is the prediction of a certain outcome when something occurs. Prediction means the guess or the possible. All right. Next, if the probability of an outcome of an event is P, then the probability that it does not happen is 1 minus 2P. All right. So do you have any more questions?
No.
Okay,
No.
I have here slide for 15.1. So maybe next time if you finish answering that practice of course book, I will show you.
Oh
that,
my God,
right?
lesson again.
All right, unit 15.2 tomorrow. All right, see you guys.
Okay.
Thank you. Bye-bye.
Goodbye, teacher. Have a nice lunch.